Section 6.8, example 6 on page 493, we have you can graph functions of the form y equals the nth root of bx plus c using transformations. If you can simplify the radicand so that x has a coefficient of 1. This is also true for functions in the form y equals a times the nth root of bx plus c plus k. Example 6 says, how can you rewrite y equals the square root of 9x plus 18 so you can graph it using transformations? Describe the graph. Up top, I wrote a reminder of what we usually look for when we're using transformations. Y equals a times the square root of x minus h plus k, where there's a coefficient of 1 in front of the x. Since we're looking for a coefficient of 1 in front of the x, we want to check to see if we can factor out this 9 that's in front of the x from everything inside the radical. Turns out we can. 9 divided by 9 gives us a coefficient of 1, and 18 divided by 9 gives us 2. So we can factor that 9 out front. Then, since we're working with square roots, we know that if we're multiplying things inside of a square root, we can separate them into their own square roots. So this can become y equals the square root of 9 times the square root of x plus 2. Well, the square root of 9 is just 3, so this gives us 3 times the square root of x plus 2. Up here, our general form has x minus h, so I'm just going to rewrite this plus 2 as minus negative 2. For the second part of the question, where it asks us to describe the graph, we can say that the graph of y equals the square root of 9x plus 18 is the graph of y equals the square root of x, stretched vertically by a factor of 3, and translated 2 units to the left. The work for this problem is written out on the next slide. Now, in their description, they say it's the graph of y equals 3 times the square root of x translated 2 units to the left, and that is because they are trying to use just the translations. However, you can go one step back and talk about it related to the parent function y equals the square root of x. Now I would like you to try number 11, rewrite each function to make it easy to graph using transformations of its parent function. Describe the graph. We have y equals the cube root of 64x plus 128.